In this video, I'll be covering tricks for integrating even and odd functions. When f of x is even and you're integrating from the bounds -a to a, that's the same thing as integrating the function from 0 to a and multiplying by 2. When your function is odd and you're integrating from -a to a, then the answer will just be 0. These can be useful if you want to simplify your bounds for an even function, or if you have a theoretical question, or sometimes it's the only way to manually compute an odd function. So here's how you determine if a function is even or odd, or neither. A function is even if the original function is equal to f of -x. A function is odd if negative f of x is equal to f of -x. And if a function doesn't follow either of these patterns, then it's neither even nor odd. And lastly, before I get into the examples, here are a few other things to note. These are your even trig functions. These are your odd trig functions. And we have multiple even and odd functions being multiplied together. This is what their result will be. So here's the first example of how this could be useful. At first glance, this integral might seem impossible to compute by hand. But when you notice that the bounds go from -a to +a, that gives us the idea that we can test to see if this function is even or odd. So let's start by writing out what our function is. F of x in this case is equal to x over 1 plus sine squared of x. So now let's test f of -x, and that will just tell us if this function could be even. So everywhere we have x, we're going to plug in negative sign. So that's -x over 1 plus sine squared of -x. Now let's figure out what sine squared of -x simplifies to. We know that sine squared is the same thing as sine x times sine x. And we know that the function of sine x is odd. We also know that the product of two odd functions is always even. So that means that sine squared x is even. In other words, sine squared x is equal to sine squared of -x. Using that information, we can simplify this to say that this equals -x over 1 plus sine squared x. And we notice that f of x and f of -x are not the same, so this function is not even. And now we can test and see if the function is odd. So if we find negative f of x, that simply just places a negative sign in front of the whole function. So that's -x over 1 plus sine squared x. And that is equal to f of -x. And when f of -x equals negative f of x, that means the function is odd. Thus, we can conclude that f of x is odd. And we know that whenever we have a function from -a to a, and the function itself is odd, the integral will always simply equal 0. So here's a more theoretical integral that involves us understanding even and odd functions. Let's start by splitting the integral into three parts. So we have -3 to 3 of f prime of x dx plus the integral from -3 to 3 of g prime of x dx plus the integral from -3 to 3 of h double prime of x dx. So all I did there was split the original integral. Now let's use our information about the functions being even and odd. For f prime of x, we see that after we integrate, we'll have information about the upper bound, but we don't have information about the lower bound. However, we can turn this into 2 times the integral from 0 to 3 of f prime of x, because we know that f prime of x is even. And this will help us because we do have information about when f of 0. Now, we know that g prime of x is odd, and an odd function from negative a to positive a, bounds, is simply 0. Lastly, we have the integral of h double prime of x. And for this integral, we have information about the lower bound, but we don't have information about the upper bound. So we can use, since we know that h double prime is even, we can turn this into 2 times the integral from negative 3 to 0 of h double prime of x dx. Now we can integrate, and the integral of a derivative is the original function, so f of x times 2 from 0 to 3 plus h prime of x times 2 from negative 3 to 0. And from here, we can just plug in. So we know that f of 3 is negative 2. So this is 2 times negative 2, or negative 4, plus, and we know that f of 0 is 0. Now we know that h prime of 0 is also 0. So this is plus 0 minus, and 2 times h prime of negative 3, which is 4. So 2 times 4 is 8. So this simplifies to negative 4 minus 8, which is negative 12.